Hi, guys. So, as we talk about rotation and revolution, we're going to focus today on looking at the different positions Earth is in relationship to the sun. So, when a region on Earth is tilted toward the sun, such as during the summer, days are longer, and that means the sun's altitude is higher. Therefore, it gives us warmer temperatures. On the other hand, when a region on Earth is tilted away, during winter, days are shorter, and therefore the sun's altitude is lower. And as a result, we have cooler temperatures. So, really pay attention to the four positions here. Okay, there's four defining moments in Earth's revolution, which is the orbit around the sun. These moments all line up with the start and end of each season. So we have a spring equinox, some say equinox, summer solstice, fall equinox, winter solstice. So really pay attention, not just, oh, spring equinox is there, fall is here, but look at that tilt. So it's not just the position, but the tilt, if it's closer to the sun, farther from the sun, if the northern hemisphere is getting more sunlight, or if the southern hemisphere. So the spring equinox marks the beginning of spring. At spring equinox, neither hemisphere, so the north or southern hemisphere, is not tilted toward the sun. Every location on Earth, though, experiences 12 hours of day and 12 hours of night. So look at the spring equinox, and that's what defines spring equinox. Then here, spring. This is still in regards to Earth's orbit around the sun. After the spring equinox, the northern hemisphere progressively, which means it increases its tilt towards the sun. So notice from the spring equinox to spring, notice that tilt. It's becoming closer to the sun. The days then become longer, and then we get more daylight, and the altitude of our sun increases. Then after the spring, we go through summer solstice. That's the beginning of our summer. That's when the northern hemisphere is at its maximum tilt towards the sun and the longest day of the year. Keep noticing, follow those arrows. After summer solstice, we're in summer. The northern hemisphere starts to tilt away from the sun. The days become shorter, but still we get more than 12 hours of daylight, and that altitude of the sun starts to decrease. So really pay attention to the tilt if it's closer to the sun, farther, and remember we're in the northern hemisphere, so you really want to focus on what it's like for us here in the northern hemisphere. Then after summer, we get the fall equinox. That's the beginning of fall. At the fall equinox, neither hemisphere is tilted toward the sun. Every location on Earth does get 12 hours a day and 12 hours a night. So we're right here in the fall equinox. Then what comes next is autumn. That's when that northern hemisphere starts to tilt away from the sun. You probably notice the days become shorter. We're getting less daylight. That's because the altitude of the sun is decreasing. Then as we get to the winter solstice, that's the beginning of winter. At winter solstice, the northern hemisphere is at its maximum tilt away from the sun. That's when we get our shortest day of the year in our northern hemisphere. And it brings us to winter. After winter solstice, the northern hemisphere progressively tilts toward the sun. The days get longer, but we're still getting less than 12 hours of daylight, and that altitude of the sun increases. So the southern hemisphere experiences the opposite of what the northern hemisphere is going throughout the seasons. When the northern hemisphere is tilted toward the sun, the southern hemisphere is tilted away. When the northern hemisphere is tilted away from the sun, the southern hemisphere is tilted toward the sun. So really pay attention to Earth's tilt. So to sum it up, Earth's distance from the sun changes as it revolves or orbits around our sun. The change is small. Many people think seasons are due to Earth's distance. However, that's not the case.